All righty, welcome to week 5, lesson number 2. And this one is all about the chain rule, which I would say is the second most used right after the power rule. So when we learned the power rule at the end of week 4, that was pretty amazing. And the chain rule here is equally amazing. Okay, so let me show you something really quickly so that we can compare this. Let me pull out a piece of paper here. So last week, when we learned the power rule, it would have been something like y equals 4x cubed, something very simple like that. And we learned to bring the 3 down and multiply it by the coefficient. So to find this derivative, or dy dx, we would bring that and it would be just 12x, and we would reduce that by 1. And the reason why the power rule last week was just that is because right here, they always had something that had a derivative of 1. So I want you to compare this to this, and you can see that this gets much more complex. This no longer has a derivative of 1. So because of that, that gives us the purpose for the chain rule. But the beginning is just the same. It's still the power rule. So to find the derivative of y in terms of x, which is what we're doing, the derivative of y in terms of x, we're still going to do the power rule. So we're still going to take that 3 and bring it all the way down front. Technically, there's a 1 in front of there right now, right? So we're going to do exactly the same thing. Bring this 3 all the way down and multiply it. So there's going to be a 3. We're going to keep that x just like we did before. Notice that was an x and we just kept our x, so we didn't change that at all, right? So we're just going to keep that whole thing just like we did last week. We're going to bring that exponent down 1 just like we did before. So that part comes from last week. That is just the power rule. Bring that down front, keep this, decrease that by 1. Okay, but here's the new part. Since this doesn't have a derivative of 1, right now we've done the derivative of basically the outside, but we haven't done the derivative of the inside. So what the chain rule says is, well, then just do it. Just do it. Just do the derivative of the inside, and then I will have done the derivative of all of it. So then I'm going to do the power rule again on the inside, bring that 5 down front. So that would be negative 15x, and then decrease that by 1. And then you would do the derivative of that, but it's a constant, so it's just 0, and we don't usually write plus 0. So I would just leave it like that. And that's the answer that I personally enter into Newton, and it is correct. Okay, and then exactly the same thing. I just want to remind you what you do. When you have something that's not written with an exponent, you can't really do the power rule. So to just make it so that it works, we rewrite that with an exponent so that we have a power. And then I'm going to do exactly the same thing. The derivative of y in terms of x, we're going to bring that 1/2 down front. We're going to keep the function the way that it is right now. We're going to decrease that exponent by 1. And then because this has a derivative, we have to then multiply, chain rule. This part right here is the chain rule. Okay, that's the big title. The title of this homework assignment is the chain rule. So this is a big deal. So the chain rule says that I've now got to multiply by the derivative of that piece. Well, that's just a 0. And then I'm going to bring that 3 down front. So that would be negative 18x, decrease that by 1 squared. Okay, so this part is the power rule from last week. And then this is the new piece, the chain rule, because I've got to take care of that. And if you look back at what we did last week, every time this right here had a derivative of 1. So technically you could have done the chain rule, but you would have always been multiplying by 1. So it's not that we weren't doing it, it's just we were multiplying by 1. So it kind of always existed. They just kept it really simple last week. Okay, that's pretty easy, right? So then we're going to do the product rule with the chain rule. And so these are things that we already know. We've just got to add in the chain rule. Okay, so product rule we learned last week. And I'm just going to kind of put this out here just to make sure that I have enough room. So remember, the product rule is always the derivative of the first one times the second one the way it is, plus the first one the way it is, times the derivative of the second one. And notice I left a little room here because these can get kind of big sometimes, but remember the general setup. And I was telling some people at recitation earlier that if you do colors, sometimes it helps you keep everything straight. So if you take out a big bold something and get that set up, it'll maybe help you not get things mixed up. Okay, ready? The derivative of the first one. So we're going to do the power rule. We're going to bring that 2 down front. We're going to keep the function the way it is. And we're going to decrease it by 1, but that's just a first. So I'm not really going to write it. But then the chain rule says I now have to take the derivative of that piece. So that would just be a 0, and that would be a negative 4x. And make sure if you're entering this into Newton that you get both parentheses. That's why to me that red kind of helps, just so I can see what I'm doing. Okay, times the second one just the way it is. Oh, and you can change that to 2x squared plus 1 in parentheses to the 1/2 if you don't want to enter a square root into Newton. So that will be accepted both ways. Okay, ready? Times the first one the way that it is. So that would be 3 minus, just pretend like that's a minus, 2x all squared. Okay, the first one the way it is. I don't really need the red parentheses on that one. It's just weird. It wouldn't hurt, but just the, 2x squared. Oh my goodness. 3 minus 2x squared. Okay, the first one just the way it is times, ready for it? The derivative of the second one. So in my mind, I'm going to imagine this with a 1/2 power. So that means I'm going to bring that 1/2 down front. And then 2x squared plus 1, decrease it by 1, negative 1/2. And then chain rule says take the derivative of this. So that would be 4x. Done. And I'm not going to mess with it. I'm not going to simplify it because I don't want to mess it up. I'm pretty good at entering that into Newton and getting all the little parentheses and exponents and all that where it's supposed to be. So in my opinion, that's the best place to stop. Okay, so just check it. Derivative of the first, yes, times the second one the way that it is, yes. First one the way that it is, yes. And derivative of the second one, yes. Okay, I just checked my work. It's beautiful. Okay, then we're going to do the same exact thing with the quotient rule. And again, it might be helpful just while you're kind of setting it up on your paper to kind of set it up. So we're going to do the derivative of the top times the bottom the way it is minus the top the way it is times the derivative of the bottom all over the denominator squared. And if you want to set it up like that, sometimes it's really helpful. You can even set it up in Newton like this and get it all and then just go and fill in all the little pieces. That's not a bad idea too, so that it's just all there and you don't have to worry about it. Okay, derivative of the top is just 9. The denominator, the way that it is, 3x cubed minus 9. The numerator, the way that it is, and then here's the deal. I'm going to picture that that's a 1/2 exponent, and I'm going to do the derivative of the bottom. So I'm going to bring that 1/2 out front. I'm going to do 3x cubed minus 9, and I'm going to decrease that by 1. So that's negative 1/2. And then the new part, the chain rule says I have to take the derivative of this. So that would bring that 3 down front. 3 times 3 is 9x squared. Ooh, squeeze in that parentheses. Okay, that's all filled in, and these get just a little bit big sometimes, so leave yourself room. And then the denominator, the way that it is, squared. And this one actually, if you square a square root, it goes away. So if you just wanted to type in 3x cubed minus 9 there, that would be fabulous. But it'll take it just like this. So you can leave it just like this, okay? And so that's combining the chain rule with the quotient rule. And we combined the chain rule with the product rule. And then we did our just basic chain rule. Okay, let's see what else they have for us. Oh yes, trig. So now they have combining the chain rule with our trig rules. Okay, so notice number 1, we have a power rule here. And with trig, instead of the exponents being on the outside here, they're always right there. But this is really cosine of 2x to the 4th minus 4 all squared. So this is the power rule. That squared right there is squaring this whole thing. So please understand that. And then we're gonna have to use the chain rule because of this. So let's see if we can do this. So our power rule would say, bring that exponent down front, keep our function the way that it is. Don't be tricked by that. But that now came down to the first, and we just usually won't write that. Okay, now you have to do the derivative. So now it's the derivative of cosine, which if you're hopefully starting to memorize these, is negative sine. So then I'm going to multiply this by negative sine of that function just the way it is. And then keep this all straight. I then have to do the chain rule because I haven't yet taken the derivative of this. So I'm going to now multiply all of that by, what would that be? Bring that 4 down there, would be 8x cubed, and then that would just be a 0. Whoo! Look at that. You've got to keep this all straight. So this was the power rule. Bring the 2 down front, keep the function the way that it is, right? But then I've got to multiply by the derivative of cosine, which is negative sine. And then I have to do the chain rule. So yeah, it's the trig ones you've got to kind of keep things straight. So look at that really carefully. But I want to make sure you understand that that is a regular exponent. And so that means that that involves the power rule. Okay, and I picked, I think, a good one there just to kind of make sure that you keep things straight. All right, then we have 2 different kinds where we've got those lovely pictures that we have to look at. So hopefully I saved them on my phone in a way that we will be able to look at them and I will be able to explain what's going on. Okay, so for this first kind, they give us a picture like this. Okay, and it's a picture of the red one is the g function, and then the black one is the f function. And they tell us right here that the u function is the composition of f of g of x. So that's what happens when you put the g function into the f function. And they want us to find the derivative of the u function at 5. Okay, so first of all, I've got to just figure out what numbers I need. And I would do that before I go to the pictures. And so I'm just going to generally say, okay, if I was going to find the derivative of this u function, I would first need to find the derivative of the f function just at whatever that g function, we'll call it g of a when we plug in that 5. But then the chain rule says I'd have to go back and multiply by the derivative of that a function. Okay, so now I need to go up here and try to fill in numbers here. So let's go for it. So g of a says go to the g function, which is the red line at 5, and just see where we're at. So I'm going to go to the red line at 5, and it looks like I'm at 3. So the red line at 5 is at 3. So this right here, this little piece right here turns into a 3. Well, then it says, what's the slope? Remember, prime or derivative is always slope. So this is saying, what's the slope of the f line at 3? Because remember, this turned into a 3. What's the slope of the f function at 3? Well, I don't know. Here's 3. Here's the f function. What's the slope right there? Well, it looks like -1 to me. So that means this whole first piece right here would turn into a -1 because that's the slope of that f black line at 3, slope. Okay, and then I'm going to multiply that by the slope, right, of the red line at, we're going back to a, so that's 5. The slope of the red line at 5. Well, let's look. The slope of the red line at 5. Well, that looks like a +2 to me. Rise 2, run 1, right? And so I'm saying that that's a 2, and -1 times 2, I would type -2 in for my final answer. Okay, so feel free to watch that again and see if you can kind of do it yourself. The best way to learn math is just to practice it. So see if you can rewind it and pause the video and go through those steps again. Okay, but that is a correct answer, and that's how you do that. Okay, then I have another picture with one of these little table ones. I know they're your very favorite. I didn't find any that got quite as crazy though as the ones in week 4. So that's good news. Okay, so they give us this function h of x, and it obviously uses the power rule, but then it's also going to use some chain rule. And so that should look kind of familiar. So again, before I even look at the table, before I even try to do any of that, I'm just going to set up what my derivative would look like, because then I'll be able to go to this table up here and find some numbers. I don't even know if that's the right table. Yes, it is. Okay, that's good. I have so many pictures because I do so much math all day, right? All right, so power rule says bring that 4 down front. Keep that function the way that it is. This first time, you guys never change the function. And then I bring that down by 1. Okay, power rule done. That's the power rule. That's what we learned last week. Then the new part is the chain rule, which says multiply by the derivative of this. Well, this would be 3x squared, 3x squared. And then I don't know what this is, so I'm just going to say it's the derivative of whatever that is. Okay, power rule, chain rule, power rule, chain rule. And then I'm going to come up here to my handy little table, and I'm going to tell you the same thing I told you last week. If you're finding the derivative at 1, make sure you're focusing on the derivative at 1, right? We're plugging in 1 to make sure you're using the right things. All right, let's see if we can just plug stuff in. The derivative at 1 would be, I'm going to keep that 4. X is just 1. We're plugging in 1. X is just 1. So that's 1 cubed plus P of 1. P of 1 is right there. Negative 3 all cubed. So that matches that. And then times 3 times, well, X is just 1 again, plus P prime is negative 5. There, I plugged it all in. And so now I just get to simplify that. So 1 cubed is just 1. 1 plus negative 3 is negative 2. Negative 2 cubed is negative 8. And then this would be 1 squared is just 1. 3 times 1 is 3. 3 plus negative 5 is negative 2. 4 times negative 2 is negative 8. And negative 8 times negative 8 is a positive 64. Correct answer. It feels so good when you get done with those and you get them right. Same advice on those that I gave you last week, slow and steady. Slow and steady. The worst thing you can do is just mess up on order of operations or something when you did like the hard part right. This is the calculus part, but you're not allowed to stop there. This time you have to go, go, go. And so the worst thing is when you make a mistake somewhere in here. So slow and steady on those, especially if one of those shows up on like a quiz or a test, super slow. Check your work, make sure your order of operations is right. All right, and then I selected 2 that come from what's called composition of functions, which is basically just the foundation of why the chain rule works. This is not difficult, so just don't let your brain get confused by this because it's really not that bad. Okay, so they give us 2 functions, a y function, but it uses the u variable, and then a u function, but it uses the x variable. This one, if you take the derivative, it's dy du. And this one, if you take the derivative, it's du dx. And they want you to find dy dx, which means we've got to stick this guy into here somehow. And there's really 2 ways to do it. So I am not going to do it the way where you literally take this and substitute it in and then find the derivative. But I want you to know that works. But it won't work on all of them, like when you've got like cube root functions and stuff. So I'm going to do this the way that works every single time because that's just better. So basically what works every time is we're going to find dy du on this one, which is just the derivative. And then we're going to find du dx on this one, which is just the derivative. And then we're just going to multiply them together to find dy dx, because notice if you multiply these du's cancel, right? And you're left with dy dx. So I'm just going to find this guy, multiply, done. And so it's not that bad, and this works every time. Okay, so just don't get overly confused. It's just the same thing. So power rule would say bring the 4 down front. So that's 20. U, decrease it by 1 cubed. And then 2 is just a constant, so it's 0. So that's it. There, that wasn't so bad, was it? And then we're going to do the same thing here. Bring the 3 down front. 3 times 3 is 9. X, decrease it by 1 squared. And then the only problem is because I'm finding dy dx, the only variable I'm allowed is x. So the only thing you have to remember is to change that u into a 3x cubed. And then we're just going to multiply these together. So I'm going to keep the 20. I'm going to change the u into a 3x cubed. And then we're going to cube that. So this is this. These are the same thing. And then I'm going to multiply it by that. 9x squared. And that is dy dx. And if you look at it, it really is just the chain rule. It's 4 times 5 is 20 times this function, decrease it by 1 cubed. And then the chain rule would say do the derivative of that, which brings you to that. So it's really just another fancy way of doing the chain rule, but don't let it confuse you. Okay, just remember that this piece is this, and then this piece is this. Done. Okay, and then they ask you basically to go backwards. They give you a function and they want you to pull it into the 2 different pieces. This again is just not difficult at all. I want you to just imagine that this is like the function inside the bigger function. So for the first one, for the y equals, you need to look at the outside function, and we need to write it with the variable u. So this whole thing is just going to turn into a u, and then it's to the 7th power. So that whole thing is just something to the 7th power, something to the 7th power, something to the 7th power. Then you need to tell me what the something is. Well, the something is what's inside here. So that's 14 minus 5x cubed. So this one is your outer function, and then this one is your inner function. And they'll ask you to type those in, and it shouldn't be too bad. Okay, so to the best of my knowledge, those 9 problems cover what you're going to see in the second homework assignment for week 5. And I can't wait to see you at recitation, and let us know if you need any help. I hope that was great. Thanks, guys.